Hey guys, welcome to this session by Great Learning. My name is Anirudh Rao and I'll be your mentor for this session on machine learning. So we're going to check out all the basics of machine learning and we're going to make sure that you guys can get started with this wonderful domain. On that note guys, I hope all of you are having a beautiful day today. It's a bright sunny day here in Bengaluru and I welcome you all from wherever it is that you are tuning from across the world. I hope all of you are keeping safe from the ongoing pandemic. Right. Now guys, before we even go on to begin with the session, let me just take a minute of your time to guide you about an amazing venture we have here at Great Learning. Now this is called Great Learning Academy, where this is a platform where we're trying to provide courses for free on multiple domains. Now you have hundreds of courses which we put out in multiple different languages. Now for all of you guys who've been asking for courses in Hindi and other languages as well, we do have all of these courses right now. It's a pretty simple thing. You can reach this particular venture of ours by just heading to greatlearning.in/academy. Now here is where you can see all the courses. Let me just click on, for example, machine learning. Right now look at all the domains that we cover, right from data science, machine learning, all the way to interview preparation. Guys, now one important thing that I have to mention for you all is no matter where you are in your career right now, right, you might be a fresher right out of college, you might be still in school, you might be still going through your undergraduate program, your graduation, or wherever it is, right? It is vital that you know here at Great Learning Academy we have something for all of you all, no matter where you are in your career right now. Right now, if we go on for example to the domain of machine learning, let me just click on one of these courses. Now you can get a complete detail about all of these courses. Again, all of these is completely for free, guys. You can enroll for free, you can learn for free, and upon completion you will get a free certificate of completion as well. That is again complete right from the start of your learning till the end where you have a certificate of completion, right? It is totally free. Now that is the advantage we're trying to give you here at Great Learning Academy. Now for more details, again, you can find out everything about this course. Now I just opened up data visualization with Python. You'll find details about this course, what are the skills that's covered, syllabus, the project that's being handled, and a certificate which is going to look like this as well, a certificate of completion. And you can find a lot of other details. This is a very, very popular platform. We have 3 million plus monthly viewers, we have 1,000 plus hours of learning content, and we have 500,000 plus learners from 140 countries across the globe making complete use of Great Learning Academy. So if you haven't checked it out, I highly suggest you do. You can reach this particular platform in multiple places. You can directly go to greatlearning.in/academy, a simple Google search, or of course we have our own application, the Great Learning app. You can use the app. You can get it right from the Apple App Store or of course the Google Play Store as well. So you can use any one of these sources to make sure that you can easily reach out to these. And if you keep scrolling down, right, this is my point, you can see all the live sessions that we have as well. For example, this is the session that you are tuned into right now. You have all the details of all the upcoming sessions and more, so you'll get a bunch of details if you check this out. Right guys, now back to the presentation. Now guys, one thing that I absolutely love about you guys, the audience, is that you always keep this session highly interactive. So I absolutely love mentoring in a session where you keep asking all of your questions and we can work through, we can have an interaction with respect to machine learning, right? So it's going to be a highly energetic session. Make sure you're just putting out all the questions that you have there and I'll be more than happy to answer them for you. Right now guys, do take a second to subscribe to the Great Learning YouTube channel if you haven't yet, and make sure you hit the bell icon as well, because now more than ever it is important that you stay in touch with the channel. We keep putting out very, very important videos on multiple domains on our YouTube channel. If you are subscribed and if you hit that bell, right, you will get a notification as soon as we put out a video. That is very important and I thought I'll convey that for you guys. And if you do like everything that you see on your screen and of course through the session, do take 1 second to hit that like button. It'll go a long way in showing support for us and of course helping us bring better content out to you as well. Right guys, now here are some of the session takeaways. Here's the agenda of the session, right? First of all, we'll take a quick introduction to understand what machine learning is. After that, we can check out why we require machine learning in today's world. Once you know why machine learning is needed, you will have further curiosity to understand the types of machine learning, the algorithms and all of that. So we're going to be checking all of that out in detail. We're going to check out the entire process of machine learning itself, of how it works in a very clear and a concise architecture. And after that, we can understand how important is Python for machine learning, and we can eventually work our way towards looking at a hands-on demo with Python, right guys? So I have all of your questions. I'm monitoring all of your questions on my mobile phone, so just keep it coming, guys. All right, now let us begin. First of all, you have to really know this about machine learning, is that it is one of the most important aspects of data science out there right now, because machine learning is the intermediate pathway so that which will take us from data science all the way to artificial intelligence, right? Now, artificial intelligence is the product, but to get to that product, we have to go through machine learning, because this is one part of us teaching a machine how to do our tasks easier, right? Now, in artificial intelligence itself, it's a big umbrella. It consists of machine learning, it consists of deep learning and many other concepts. But machine learning being a concept, you have to know that it is among the most trendiest concept. Of course, artificial intelligence, which you already would know, right? To get to that, you have to have a knowledge about this. Now, machine learning always talks about how you can use machines in a way where it can learn on its own without us having to intervene every time out there, right? So we provide certain data to the machine learning algorithm. We provide the output and say, hey, okay, so just show me how you can work with the data on your own and find out what insights you can provide, right? This is a general conversation. If you were talking to your computer and assigning it a task and it giving the answer to you, that is a very simple transaction in machine learning. Of course, we're going to check out all of this in detail. But the eventual goal of machine learning that you really should know about is to make computers more human-like. It is to give that human touch in a way where you wouldn't be able to differentiate between a computer and machine performing a task. Of course, a machine can perform a task maybe 100 folds or 1,000 folds faster than a human being. But the point is that we have computing power, we have ample amount of data. So let's bring both of these together and make sure that all our processes are efficient, right? But then when you're talking about machine learning, where does all the data come from? Well, we do have data sets. Now, data sets are these entities which consist of data. They might be in the format of CSV. They might be stored anywhere on your server, cloud computing platform, wherever it is. Now, using all of these, your machine learning algorithm is going to use certain data because it knows zero. You are trained for so many things. I'll just mention all of this in the session ahead as well. But your machine does not understand. It understands only zeros and ones at max. Right. Now, you will have a question saying, okay, so why is machine learning required in today's world, right? A lot of different reasons of why machine learning is required. First of all, if you're looking at machine learning, understand this: you are increasing the performance of a process by 1,000 times, or let's say even 1,000,000 times. So what does it do in terms of reducing your workload? At the end of the day, if your workload is low, you can do more productive tasks, and eventually brings down all the production costs in an environment, right? In an actual environment. That's the most important point. Second thing is that you can process huge amounts of data, and your machine learning algorithm can do it with ease. If that were a manual task, it would really be a pain to go on to process through a lot of manual data. Now think about going through maybe 10 or 15,000 rows and columns worth of data on an Excel sheet manually. Now that is nearly impossible for a human to do, right? It's very cumbersome. This is where a machine learning algorithm can do it in maybe 30 seconds? Literally that, right? And the next thing is that data, as you talk about it as an entity, right? Data is like a treasure trove. Once you start digging into it, once you start understanding the data, it will give you so many hidden things. It will give you these insights. These insights can be used to understand what went wrong in the past about the business, or in fact how you can go ahead in the future as well. Now, having the ability to predict the future by using past data, that is magic in my opinion, and with machine learning that is highlighted a lot. So finding these hidden trends and getting ahead of the competition in today's world of, you know, immense amount of competition, that is exactly what we try to achieve here as well. Right. Now, talking about the types of machine learning itself, there are three important types of machine learning that you guys should know about, guys. Make sure you have a pen and paper and handy. It will be very vital if you can note down these three types of machine learning. We have supervised learning algorithms, unsupervised learning algorithms, and reinforcement learning algorithms. Now, when I say algorithm, what do I mean? Algorithm is basically a structured way of how one can work with the data. You have an input, you have data, you use the data and an input to give you an output. In the case of machine learning, the process itself is called as training the machine learning algorithm. The entity is the machine learning algorithm. But what is the output called? Now, once you have an output, it's no longer called as a machine learning algorithm, guys. It's called as a machine learning model. It is very important that you know this. So whenever someone says, hey, I use this machine learning algorithm and I got this output, and if they still call it machine learning algorithm, that is an incorrect terminology. The correct terminology to use after your machine learning algorithm has worked with the data is calling it a machine learning model. Right. Now, I hope this is clear. Let us move to the first type of it. Now, the first type of learning itself talks about supervised learning. Now, what does supervised mean? Well, supervised literally means that if you are the person who's learning, you have some sort of supervision, right? You know what you're doing. You have some sort of guidance when you're learning. Guess what? It's literally the same in the case of machine as well. Now take a look at all the images that are present on your screen. You have pictures of flowers, a dumbbell, and a car as well, right? Now, even if I remove the, even if I remove the text below these images, there's a good chance you can take a guess as soon as you look at it, right? As soon as you look at the first picture, you'll be like, okay, those are flowers and stems. The second picture, you're like, they're weights and dumbbells and gym, something like that. The third thing, you'll be like car. And if we have any sort of car enthusiast here, you can even point out the model of the car, the color of the car, the brand, all the details about it, right? Now, you know this because you have been trained from your childhood. If I show these images to a machine learning algorithm and not give it any context, it will not understand anything. So in the case of supervised learning, what we do is we tell the machine, hey, here's an image of a flower, and we say it is a flower. We give it a confirmation saying, yes, this is a flower. And we show a dumbbell. We say, hey, this is a dumbbell. We give it a car. We say that, yes, this picture that you're seeing is a car. So that way it knows for sure what it is seeing, right? So the data that we give to these images, they are called as labels. Literally the label, whenever you put a label on anything, it is to make sure you're highlighting something, right? Literally the same concept here, guys. So one important thing that always comes to talk when people go on to talk about supervised learning is one important formula which you might have heard. It's y is equal to f of x. Now this simple phrase, y is equal to f of x, I would say equation instead of phrase, is literally the foundation of supervised learning. Now why do I say this? Well, you have to understand one thing. In supervised learning, right, we map inputs and outputs and we assign some function to take the input and see if there is a relationship towards the output, right? For example, look at your screen right now. Y is equal to f of x. What we're trying to say here is x is the input variable while y is the output. But to get towards y, you have to map x and find a relation to y, right? Y is the relation. Y will give you the relation when you add and map a function. So it's literally mapping the output and considering a function of whatever input that you're giving. Now, if you give the picture of a car and if you say, hey, is this a car? Now, it has to have a methodology to understand to see if it's a car or not, right? That's exactly how it works in supervised learning. It knows what it is seeing, but it will try to guess based on its knowledge. This is literally how supervised learning works. All right, let me take a look at the comments. Ayush says, I am newbie in machine learning. How can I learn it from beginning to advanced? Well, Ayush, we do have a basics of machine learning course on Great Learning Academy. After the session, do make sure you are enrolled in that course because that will help you get started with it. Now, Sumed guessed the car model, right? So Sumed knows. Sumed has been trained to know what car it is, but a machine learning model is not. Right. Coming to the next subdivision in supervised learning itself. Supervised learning is broken into two things. One, we have regression, the other we have classification. Now in regression, what we're trying to do, when we say regression, we are trying to predict something from the future by making use of the past data. For example, weather prediction, right? So how do you know what the weather is going to be like tomorrow? That is the regression concept. Take a look at classification. Classification literally talks about how you can categorize things. Now, if I give you 3 apples and 2 oranges and if I jumble it up and give it to you, you know that you have to place all 3 apples on one side and 2 oranges on the other side, right? Literally the concept of classification. Grammatically, it holds sense even in the case of machine learning. So you're trying to classify certain things. So this is how supervised learning is divided into regression and classification. Perfect. Now, let's talk about unsupervised learning. Now, unsupervised learning is very different to supervised learning. In supervised learning, you tell the machine learning algorithm what it is seeing. You give the label to the data. Here, you do not. You just show the images to it and you say, okay, so what is it? Right? So you literally are making your machine learning algorithm work, understand something about the data, to find structure in it, to find meaning in it, and then give you an output. This is how different from supervised learning itself, right guys? Because when you think about it, supervised learning algorithm, you're giving the input, you're giving the output and saying, map me a function from this to that. Here you're saying, hey, here's the input, here's the output, show me a structure, find me a way to get from here to there. What kind of learning do you have to do to find a similarity in a concept that I'm showing for? That is unsupervised learning. As you can see right now, I do not have a text which says flowers or a text which says dumbbells or a text which says car here. The machine learning algorithm will figure that on its own. That is the magic of unsupervised learning. Now, if we're talking about how unsupervised learning is broken into two things, it is broken into clustering and association. Now, clustering is very similar to classification, but here what we're trying to do is we're trying to group everything which has similar characteristics. Now, if I have 10 cars parked, maybe 4 cars are blue, 3 cars are black, 2 cars are white, something like that, right? Now, all of this is mixed up. You can eventually separate out and cluster each of these and park them in different places, right? To just park them in a matching fashion. You can do that. That is clustering. Next, when we're talking about association talks about, I'll give you an example. Let's say you watch something on Netflix. You watch a TV show. At the end of an episode or at the end of the TV show, it's gonna suggest another TV show to you, saying, hey, people who watched this TV show also watched that. Now, how does Netflix know what people have watched, what they're watching next, what they like, what they dislike, right? Netflix uses an amazing amount of machine learning and artificial intelligence, even though it doesn't seem like it. They make sure that they give you the highest quality content that you like, so it feels very personalized and customized, and it keeps you hooked to the platform itself, right? Now, to do that, to engage with you on a personal level, there is a very nice machine learning, deep learning, and of course an AI model working in the backend for that. Right, now these are the types of unsupervised learning. Now, let's talk about the third type of machine learning, which is reinforcement learning. Now, with reinforcement learning, there is one important thing that you have to know. Here, we do not train on data, we do not train on labels, we do not train on parameters. We have two very important things we train on. It is basically a reward and a punishment. Now, I'll give you an example. Now, guys, you head to the comment section. I'm watching the comments right now. Head to the comments and tell me if you have a pet dog. A pet dog maybe, or a pet cat. But I'll tell you, a cat will not work because I've been owner, I've had multiple cats. They do not hold true for my explanation now. But if you have had dogs in the past, or if you have pet dogs right now, when you've seen professional trainers train a dog, right? They give the dog a lot of training. So one important training that you can see where reinforcement learning works in real life is when they train the dog to give a handshake. Now, when they tell the dog to give a handshake, well, the dog might not understand English at the start. It might not know how to give a handshake. But eventually, if you lift its leg and give, sort of force it, or just not like force it in a bad way, but just get the handshake from the dog, and as soon as it gives the handshake, the trainer will give it a biscuit or a treat, a reward. So what the dog thinks is that, hey, so if someone's asking for a handshake and I give a handshake, I get a reward. So the dog works towards the reward all the time, right? Now, let's say you ask the dog for a handshake, it doesn't give a handshake, so it just runs away. Well, guess what? It is not getting a reward. Of course, in this case, it is not getting punished in any way. But in the case of a machine learning algorithm, if the dog was the machine learning algorithm here, it would get punished. But in real life, of course, I do not know no one. Okay, so we have a lot of people who say yes. Pooja Nayak, Sumed Yadav, yes, cat. Well, Sumed, I am not sure if you can try this with your cat. Cats can be pretty aggressive sometimes. I have owned multiple cats in the past, and if you train a cat for a handshake, it would rather just meow and run away and not care. So yeah, but dogs it works. So that is how reinforcement learning works, guys. Your machine learning algorithm will always hunt and work towards the rewards. That is the most important thing, right? Now, yeah, so see, you guys see the hilarity of it as well, right? So it works on dogs and not on cats. Now, coming to the next aspect of it, you will have a curiosity to check how machine learning itself works, right? So how does a machine learning model learn? When I say how does a machine learning model learn, you see, I use the word model and not the algorithm, because once it learns, it becomes a model, right? Now, to check out how a machine learning model learns, I have to guide you about the data itself, because it uses the data to learn, correct? In the case of machine learning, data is split into two things. One is the training data and one is the testing data. Training data is literally what the machine learning algorithm will use to learn. And testing data is when we verify, we provide the data which it has never seen before and verify if it has learned something. Now again, think about your college test. Your textbook can be considered as the training data. The examination you go and give can be considered as the testing data, right? That's the difference between training data and testing data. Training data, the machine learning algorithm knows completely. The testing data, well, it's a surprise even for it to see if it has learned anything, right? For the verification of it. All right. Yeah, my cat scratched me on my face, as Pooja Nayak. Paulomi says, I trained my dog in this way. Well, Paulomi, you used you used reinforcement learning to train your dog, now that you know this concept. Okay, so Rahul has a very nice question. How can machines be trained? They don't like biscuits. Guess what? Machines have a very simple life that they lead. As I told you, right? Zeros and ones is all that they understand. So a 0 can be considered as a punishment and 1 can be considered as a reward. When you're training a machine learning algorithm, if it gets closer to the accuracy, it will be rewarded with a metric, a number which it can track and understand. So if its goal at the end of the day is to try a lot of different things, but understand and learn what brings that metric up. What is the tracking metric we're using, the number, the percentage of accuracy. Keep bringing that up. That is the biscuit for our machine learning model. Right, good question, Rahul. I wish computers liked, biscuits. All right. Now, this is how a machine learning model learns, guys. This is the timeline. So let's work from the top left. First of all, in the machine learning model process, when you're implementing a machine learning model, you have to understand what the problem is. Because now, what is machine learning? Machine learning is a concept which we're using to solve a problem. Everything you see in the world of information technology exists because there's a reason, and the reason is usually a problem, right? There is a problem which we are trying to solve here in machine learning as well. We are trying to get the machine to do something, very efficiently when you compare it to human beings. So the first step involves, of course, you understanding what you're trying to solve. Once you know what it is that you're trying to solve, next you start gathering all the data which will help your machine learning algorithm learn. This is the phase of data acquisition. Once you have the data gathered, it can be stored in a database, it can be stored in a CSV format, it can become a data set, all of these, right? The next thing which you have to do is not directly feed it into a machine learning algorithm. It is to make sure you clean the data. Now, data is a very raw entity. You cannot work with raw data because a machine learning, if your data is wrong, right, if your data is wrong, your machine learning algorithm will start learning it wrong. Now I'll take the same cat and dog example. If I show you a picture of a cat, if I show you a picture of a dog, you will know which is which, right? Because probably from your childhood you have been trained on it, you have learned it in your school, you've seen thousands of dogs and cats in your lifetime. But your machine learning algorithm does not know what a cat looks like, does not know what a dog looks like. So if I provided the wrong data, it will say, hey, this cat is a dog, and it will confidently say it. So that is not something which we want, right? We want it to predict correct. Now that is exactly my point out here. You have to clean the data. If you clean it without discrepancies, your machine learning algorithm will work fine. Else, there's a good chance it's going to give you nonsensical outputs, which eventually will be a waste of your time and effort. Now, after data cleaning, the next step to understand how a machine learning model learns is to perform some data analysis on it. EDA, or exploratory data analysis, is a very fine concept that we use to go into the depths of data, to understand the data ourselves first, to see if we can pick up any insight from it. For example, if you are if you guys are wondering about the practical demo that I'm going to show you now, it's going to be something about diabetes. Now, diabetes is a very huge concern in today's world, right? So how would you make a machine tell if a person is diabetic or not, right? So to make that sure, you need something to track. You need these metrics to measure if the person has diabetes or not, and a lot of different things. So you yourself have to look into the data to understand it. That is EDA. Next, once you say, okay, so I can use this data to get this parameter to understand this aspect of machine learning, you send all the data to the machine learning algorithm, and once your machine learning algorithm has learned it, then you give it the testing data. You showcase the testing data, cross-reference it with the training data to see if it has learned anything or not. So once it has gone to learn that, once it says, hey, I have learned it and I use the testing data to predict it, it's going to give you an accuracy score. It's going to say, so, okay, this is what I could learn on my own. This is how much of change there is from the testing data. So eventually you can work out an accuracy rate there, right? Now, after you have the accuracy rate, you have actually solved the problem. Then it is a matter of you just, working on maybe different data, or you deploying the model in a way where it is eventually used for the final solution, right? So this is the entire process of how a machine learning model learns, guys. Okay, Sumit says, thumb rule, while training the machine learning model, we always have to make a data set numeric. Well, Sumedh, there are multiple types of data. There's categorical data and numerical data. Now, in the demo that I'm going to show you, your point is fantastic. We are, going to check out a numerical data set, but a picture of a cat or a picture of a dog is not numerical. That is categorical, right? So you are halfway right, but in all the cases that will, not be the case. Aniket says, is maths required for machine learning? Yes or not? Please tell me. Well, you will require a lot of knowledge on statistics and mathematics. So my simple answer is yes, you will require machine learning. To understand machine learning in depth, you definitely require mathematics and the concepts of statistics. Perfect, guys. Now, to move on to understanding, the usage of Python for machine learning, right? Python, as you guys might know it, is the #1 programming language in today's world. It is extremely popular and it is the preferred choice for machine learning out there. Now, there are many different languages. When you're talking about data analysis, you have the programming language R programming. Guys, have you heard of R programming language? If you have, just go out to the comment section and just put a quick yes, because R is very popular for data analysis. And similarly, Python, right? It is known and it is used very well in hundreds of domains, wherever you think about it, right? In the field of medicine, in the field of web development, in the field of gaming, in the field of artificial intelligence. I can go on and on and on, guys. Right. Now, what you have to understand about Python is that it is very, very easy to work with. It is easy to understand the language itself, and the syntax that it provides, right? It is absolutely beautiful. Now, I've been working with Python for years together now, and once you get used to Python, it is very difficult to to adjust yourself or to learn another programming language itself, because Python is that easy to work with, and once you get used to it, it becomes convenient to go on with it, guys. So you might have a question saying, so okay, how can I go on to install Python? Is it difficult? Do I have to work a lot towards setting up Python itself? Again, the answer to that is no, because installing and working with Python is extremely easy. You can go to the Python website and download Python for Windows, and you can get started with it really quick. It's a matter of 4 or 5 clicks, in fact. But then, when you're working with a programming language, it is very useful if you have used an integrated development environment, or an IDE as we call it, right? Now, for Python, there is many IDEs, but the most popular one being PyCharm. PyCharm is a really nice tool to work with if you're working offline, and of course, you can get Python from multiple different offerings as well. You can pip install Python, you can use the pip package manager, you can use the conda package manager or the anaconda. You can just click anaconda Python and you can search for it in Google, and it will give you a very simple result of how you can get it all set up as well. But there is one more place where you can work with Python very easily, that is Google Collaboratory. Google Collaboratory is basically a Jupyter notebook that is hosted on the Google Cloud platform. So literally, if you're on your phone, your laptop, your iPad, or whatever it is you're doing, wherever you are in the entire world, you do not have to have your code physically with you. If it is just on the cloud platform, Google will give you a good amount of storage, a good amount of computing power for free. You can run all your code. You do not have to install Python locally. You do not have to work with any runtime issues, complexities, dependencies. No, it is literally just go on to Google Colab, start writing your Python code, start executing. That is it. That is simple. And I'm going to be using Google Colab in the demo that we are about to check as well. Now, in the case of machine learning, right, there are 2 or in fact 4 libraries which are very, very popular. 2 of these libraries are Numpy and pandas. Now, Numpy is used whenever you're working with array data or multidimensional data, right? For example, in your school or colleges, you might have learned about matrices and matrix. Well, to make your machine understand this kind of a 2-dimensional, 3-dimensional data, you require Numpy in the case of Python. Pandas is used for data manipulation. Now, sometimes you'll have to store data in a structured way. You will have to work with it. You will have to modify it, change it, and make sure that Python understands it and your machine learning algorithm also understands it, right? For that, we require pandas. So Numpy and pandas, especially for numerical computation and data manipulation, these 2 libraries are absolutely amazing to work with. If it weren't for these libraries, I think Python would be a pretty difficult language to work for machine learning. But thank God, all of these are open source. You do not have to pay anyone anything to use all of these libraries, and of course Python itself. Right. Now, I am going to tell you one very important concept. This is where your traditional way of solving problem differs from machine learning. Now, this is a very interesting thing that not a lot of people know. Guess what? In traditional programming, what happens is that you have a program which you will write, you will have certain data. Once you tell your computer that, hey, here's the data, here's the program, it is going to churn all of that and give you an output that you can use, right? Just think about C or C++, or in fact, anything in Python itself without machine learning. Now, machine learning is very different. Machine learning, you will tell the machine itself what the output is like. You're like, hey, here is the data, here's the output. Use the data to get to the output. Map a relationship by learning from the data and taking us to the output. So that eventually will give you a machine learning model, as you can see, right? Your machine learning model will already know the output. It will already have the data at hand. So it has to give you a relationship. That is the very important difference that exists between traditional programming and machine learning. Right. Now, to check out machine learning algorithms, there are many different types of machine learning algorithms. Of course, all of these machine learning algorithms will come under the same domain of supervised learning, unsupervised learning, and reinforcement learning. But here are some of the popular machine learning algorithms which you really must know if you are very serious about machine learning. You have linear regression, logistic regression, naive bayes, KNN algorithm, SVMs, which is basically support vector machines. You have random forests and and many other algorithms as well. Now understand this, these are not types of machine learning algorithms, these are the algorithm themselves. These algorithms can be classified into supervised, unsupervised, and the different categories under which the algorithms come from. These are those categories, guys. Right. Now, let us pick up one of these things, right? Let us take a look at logistic regression. Now, logistic regression, when you say logistic regression, the first question you might ask is, what is a regression? Well, I already told you what regression means, right? Think about the weather prediction example that I gave you. You're going to predict something in the future by having the data from the past. So what you're trying to do is you're trying to model a variable in a way where it understands the relationship between an independent variable and give you an output based on that. That is logistic regression in a very simple fashion. Now, if you talk about machine learning with a lot of people, there's a good chance they'll say, hey, linear regression, logistic regression. So this term regression is very popular. Now, why is that case? Well, it is that case because it gives out this very nice relationship which is called the cause-effect relationship. If something occurs, why did it occur, right? So that relationship, whenever you're trying to map with regression, you can do it. You can find all the factors which will affect the weather tomorrow and eventually map a relationship, right? If it is super cloudy and you have maybe black looking, very dark looking clouds, in that case, you can have an effect saying, okay, so if this is caused, the effect can be a rainfall, a heavy rainfall or a snowfall or something like that, right? That is exactly, my point here. Now, to understand more about logistic regression itself, logistic regression is a part of the supervised learning algorithm. Now, in supervised learning, you already know this, we provide the label to the data, right? With logistic regression, the difference is that, or an important understanding the way of working is here we are trying to get a probability of what's happening. It is a binary output that you will get out of linear regression, right? So when I say binary output, it will be 0 or 1, true or false, yes or no. So to answer any of these questions or to get to these conclusions, you will be using logistic regression. Right, guys, the number of comments have come down, so I would really like it if you guys put on more comments. And guys, do take a second to like the video. If you're loving all the content you see on your screen, it only takes a second to hit that like button, but it goes a really long way in supporting us. All right. Let me just get a quick gulp of water and we can continue. Right, guys, perfect. I'm still waiting for your comments. Come on, let's keep this very interactive. Head to the comments and do put them down. And now we are going to practically check this out in Python, right? So for this, a small prerequisite is that you have to understand Python syntax. You have to know a little bit of working with Numpy and pandas and certain libraries, right? So for machine learning, there is one very important library. It is called as scikit-learn. Scikit-learn is a very popular library which is extremely powerful and a beautiful library to work with. It's really easy. And in case if you guys have not been initiated into machine learning, right, in case if you have never worked with it, you might be wondering saying, okay, so do I have to write hundreds of lines of code to solve a simple problem in Python? With machine learning, I will tell you this: 2 or 3 lines of code is exactly what you would use to train an entire machine learning algorithm, as you will see in the demo that I'm about to show you now. Okay, so anyway, coming to Great Learning Academy, guys, I hope all of you checked out Great Learning Academy. You can learn, upskill yourself and get a certificate of completion for free as well. So if you're looking out for any domains, right, just put them in the chat box. We have people who are replying to all of your comments in the chat box as well, so the team will help you get to your desired course on Great Learning Academy. Perfect. I'm going to close both of these now where we can get to Google Collab, right, guys? So this is Google Collab, as I just mentioned. You just have to go to collab.research.google.com. Let me super zoom so all of you guys can see it on your small screens if you have logged in from a phone or if you have logged in from a laptop or something like that. All right. Now, to show you how easy it is to just put down a simple Python code and work with it, right? Let me just go on to print something. Print Hello learners, right now I have not installed Python on my computer, but if I just go on to hit play, guess what? It printed it out. So Python is running with me absolutely not having to install dependencies, not using a very complex IDE, not setting up the environment, all these complex things. It is gone. Collab.research.google.com. Just create a new code block, write your code, hit the play button, you are good to go, right? That is how simple it is. Anyway, guys, now coming to what we are trying to achieve here with the particular demo, right? Now, in this demo, we are trying to see if we can correctly predict the onset of diabetes in a person or not. So, our data set will consist of hundreds of people who are, who are providing a lot of parameters, a lot of health parameters, which we will see if the machine learning algorithm can itself use it to learn and understand and predict if a person has diabetes or not. So, eventually, our data will have 0 for a person who doesn't have diabetes, 1 for a person who has diabetes, right? Logistic regression, zeros and ones, binary output. Remember that, right? So let's quickly go on to check what we are supposed to do. The first step in any problem solution is to import all of your libraries at the same time, because eventually it will help you not repeat it again and again and again. It will make your syntax itself smaller, right? So the first step is to import all the libraries we're going to be using. We're going to be using Numpy, Panda, Matplotlib and Seaborn are two very nice data visualization libraries for Python. It provides beautiful looking graphs. Again, I'm going to show you guys all these beautiful looking graphs that I'm talking about, but it just, when you have a graph, right, the output itself changes a lot. You will understand so many different things so quickly with the help of it. Now, the first step is to import all the packages and the libraries. One simple click and I am done. Now, all these separate imports that you see on your screen right now are the concepts which are a part of the library itself. Of course, you can choose not to do it, but if you don't do it with every line of code that you write further, you will just have to go on to type it manually, guys. Now, next, we're going to import the actual data set. So we're going to be using the concept of pandas. Pandas has a read_csv function which will basically help us import the function itself. Now, as soon as I go on to run this, it will have the data set. Now, the data set I have manually uploaded here, the diabetes.csv file into Google Collab, right? So all you have to do is you have to click on the left tab which says files, you have to click on the upload button and you are done. So using this syntax, this is basically the path where the file is stored. Right, now all thing is done. We imported the libraries, we imported the data set, but let us look at the data set itself. So data.head will basically print the first 5 rows of data. So we have so many things here, right? So we're trying to see many factors. For example, blood glucose level, we're trying to check the blood pressure level, the skin thickness, the insulin value, the BMI stands for body mass index. 25 or 26 is the normal value. If you're above that, you're obese. If you're below that, you are skinny, something like that, right? Then you have the age of the person and eventually the outcome. If the outcome is 1, it means the details of this person, right? He or she is diabetic. If it is 0, it means this person is not diabetic, right? Now, if you're wondering about, guys, you're not asking a lot of questions. Come on, ask questions. Now, why is only 5 rows printed? What do I do if I have to print 10? The default value is 5. Just put in data.head of 10 and it's going to print 10 for you. See? Simple as that, right? It's just one line of code. It's not even one line. It's like 10 characters. It can do a lot for you. Now, the next thing is, let's print out all the labels that we have, right? See, we already saw the labels here: pregnancies, glucose, blood pressure, skin thickness and all that. So let me go on to print it again. Just for your convenience, these are the column names that we have: pregnancies, glucose, blood pressure, skin thickness, all the way to outcome. If outcome is 0, person is not diabetic. If outcome is 1, the person is diabetic, right? Perfect. Again, see, it's just like data.columns. We're not even writing long form syntaxes anymore. It's all short forms. Next, we have data.info. Data.info will eventually give you all the information you need about the data set itself. Now here you can see we have non-null count basically talks about how many rows of data that you have. We have 9 columns of data, and 768 rows. Now in our case, each of this row is a person. Each of this row is the data from one individual human being, right? So in our data set, we have 768 people who are either diabetic or non-diabetic, and we're going to see if the machine learning algorithm can predict that based on all the other data, right? So we're going to check that out. But then before we do that, someone asked me, is statistics and mathematics required? Well, here is something which is very important that you're supposed to know. The concept of statistics, right? Mean, median and mode are basically the measures of central tendency in the concept of statistics. You do require that. So count will basically tell you how many rows of data you have. We have 768 rows of data. Mean will give you the average of all of these individual columns, right? So it's going to add up all the rows, give you the average glucose value of all these 768 people. STD stands for standard deviation. Min stands for the minimum value. 25, 50, 75th and the max numbers stand for a percentile. Now here's the concept of statistics. It's called as the interquartile range. We are going to divide the data into 4 different entities, Q1, Q2, Q3. It's called as quartiles. Minimum to Q1, Q1 to Q2, Q2 to Q3, Q3 to max. Now this Q1, Q2, Q3 points, they are the 25th, the 50th and the 75th percentile of the data. Now of course for this particular solution you can get through it without understanding all of those in detail, but to know what it means here, you definitely require the knowledge of statistics, guys. Right, now the next aspect of it is us pre-processing and cleaning the data, right? Now to go on to clean the data, it becomes very vital. As I told you, if you do not clean the data, your machine learning algorithm learns wrong. So what we're trying to do here with data.isNA basically is checking for any values which are not numbers. Now as soon as I go on to run this, it says false. What does it mean by false? So when it says false, it means that all of the details that you're giving here, right, all the individual elements for each of these rows, they are all numerical data. They are not categorical data. Now I'll give you an example of how your data can be messed up. Think about age. When someone asks you what is your age, you say it's a number, right? You do not say my age is orange. You do not say my age is a BMW car. It doesn't make sense. Your age has to be a number. Your blood pressure has to be a number. Glucose level has to be a number. So here we are just checking if there are any of these nonsensical values which will teach the machine learning algorithm wrong stuff. In our case, we are using a data set which is already pre-processed and cleaned, so we do not have to break our head about that. Right. The next thing we're going to check out is another concept of statistics. It's called as correlation. Now let me quickly zoom out a little so you can see what I mean. So this is basically a map, a colorful map which will tell you how two variables are closely knit to each other or not. Now a practical example of correlation is like a magnet, right? If you put two magnets in two very far away places, they will not attract to each other. Now you start bringing it closer, it is eventually going to like either repel or attract, right? This kind of a repel or attract will basically talk about how the magnetic forces are related. Here itself, again, we have two values where we're trying to find how these two values have an impact on our output. Now on the right of the legend, if it is black or if it's a dark color, it means the value on the x-axis and the value on the y-axis are not really related too much. Now, I'll give you an example. For example, think about, here is the black element, right? So what do we have here? It says age, and what do we have here? It says skin thickness. So what it is trying to tell us here is that, hey, skin thickness and age do not have a correlation. Hand in hand, they do not have an interdependency or a huge impact on the output. That is what we're trying to find out. But if it's a very light color, it means that it is highly dependent on it. For example, the glucose value is very much dependent on the outcome, right? If you have a blood glucose value which is like super high, regardless of whatever it is, there is a good chance you might have diabetes, right? So that's why it says outcome and glucose. If you just check this, glucose has high correlation with the outcome. So glucose has a lot to do with the output is what I'm trying to say here. So to map it out in a very nice way, we just put out the correlation metrics, guys. So, and one more question that you guys have not been asking is, why is it all blank on the diagonal, right? So why is it all just white? It is all white because you cannot compare two of the same things, right? See, for example, if you just pick pregnancies here, it's white. What is on the x-axis? It's pregnancy. So how would you go on to compare pregnancies and pregnancies themselves? So it is not possible, right? So that is why you cannot compare the same thing with the same thing. That's why all these are white. Perfect. Next, let us check out how many people have no diabetes in our data set, right? It's a very simple. Let me zoom in. Perfect. So all we're trying to do is, you remember the outcome column that I showed you? We're just using the outcome column and we're trying to see how many zeros are there, and we're trying to add up that count. We're trying to see how many ones are there and add that count. All of the columns, all of the rows that have zero basically is talking about the people that do not have diabetes. So when it adds up, a simple for loop, it will give us 500 people. So out of the 768 or so people we have in our data set, 500 do not have diabetes. Now if I just change the logic, it's a very simple thing. To find out all the people that have sugar, all I have to do is change the 0 into 1. Now as soon as I go on to do it, guess what? We have 500 people who do not have diabetes, but we have 268 people who do have diabetes, right? So instead of seeing just numerical data like this, let us quickly plot it up. Now once we plot it and let me zoom out. Once we plot it and look at it, well, see that here you have a very nice understanding, right? So 500 people have no diabetes. 200 and how much was that? 268 people have diabetes. It's a pretty, when you look at a graph, it just gives you so much more information, right? That's the point, right? Now guys, what is the next step? You have to split the testing, and so you will have a data set. A data set, as I told you, has to be split into two things: training data, testing data. Training data is used by the machine learning algorithm to learn. The testing data is later we feed into it to see if it has learned anything. So once you have data, in our case it's just one big data set, we have to split it out. Now to split it out, you can have the percentage of split between the training data and the testing data. In our case, we are, let's say if we have 768 rows of data, we are taking 80% of that, 80% of it and giving it to the training data. 20% of it we're going to give it to the testing data. Now how did I say 20 and 80? Look at this. If the testing size, if the test underscore size parameter says 0.2, it means 20% is going to test. If I change that to 0.3, it means 30% is testing. How much is remaining? 70. That becomes your training data. As simple as that, guys. So as soon as I go on to run this, our data is now split into two things: training data, testing data. Training data is 80% of the data. Testing data is only 20% of the data. Got it? Perfect. Now comes the machine learning aspect of things. Here is where you will have a question saying, okay, do I require 100 lines to learn machine learning? No. These 2 lines are literally what the machine learning algorithm needs to learn on this data, right? So we're using logistic regression. As soon as I go on to execute this piece of code, of course, it's going to say it's giving me a warning saying, the number of iterations have been reached, but that's okay. You do not have to worry about that. But these 2 lines of code is all that it takes for your machine learning algorithm to learn. Now, once it has learned, well, at this point of time, guys, it has actually learned it. At the end of it, to see if it has learned, we have to pass the testing data, right? Now look at this. To perform predictions, to see if it has learned anything at all, we give it the testing data, and it's almost like the machine learning algorithm is now prepared for an examination. We give it the examination now. As soon as I run this piece of code, it knows now that, okay, so this is what I learned, this is what I was supposed to do, and it is going to give us a conclusion. Right now the conclusion can be printed out in another measure of accuracy, a metric from the concept of statistics. It is called as it's called the measures of accuracy. Now the simple matrix that you see on your screen talks about four important values: true positive, false positive, true negative, and true positive, true negative, false positive, false negative. These are the four values that you can pick up from this confusion matrix. Now guys, since we're keeping the scope of this video to all the audience out there, I would not want to get into the complete depths of this. For again to check out in depth of all these, we do have statistic videos, we do have videos on the intermediary courses and advanced courses on machine learning as well, so make sure you check them out. But at this point of time, understand that these are a measure of accuracy. For example, this talks about the values which are true positive, so how much did the machine learning algorithm get correct, right? But to simplify it, since I know that you might not know what a confusion matrix means, let us print out the actual value, right? So the accuracy score, how accurately did the machine learning algorithm find out if a person has diabetes or not? Well, guess what? For every 100 people, it could get somewhere around 75 people correct. So the accuracy is somewhere around 74.6 or 75 itself, right? Right. Now, it is vital that you know that your machine learning algorithm, now people will be like, okay, why isn't it 100% accurate? If it was 100% accurate, then it literally has to learn a lot. You can get it up to the 80s, up to the 90s. It depends on the data set. It depends on what you're trying to do. It depends on how many iterations you have given the machine learning algorithm. Now here, when we just performed the logistic regression application, we just gave it the maximum number of iterations that it can give. You can actually change the iterations. You can have it train for 20 minutes, 30 minutes. If you have complex data, it can train for days together and then, give you the output as well, guys. So, the last thing in the demo is where we print the classification output again. Now, for the people who asked if mathematics is required, you do require to understand what precision means, what recall means, what F1 score means, and all these, right? So these are the metrics that we use to track how accurately did we predict the people who do not have diabetes, and how accurately did we predict, how precisely did we predict if the person has diabetes, right? So those are the two things which says 0 and 1 here. 0 is the amount of precision, and of course other metrics as well, to see if we predicted people correctly there, and 1 talks about the diabetic people too. Right guys, so this is a simple demo. We really did not use a lot of code. All the simple code snippets, even though you might not know Python, you could figure out most of it, I presume, right? That is the simplicity of Python. That is why it has become the #1 programming language out there. Now, I am sure that a lot of you viewers will be asking questions saying, okay, so I want to learn more about machine learning. Where can I find free content, right? So in the Great Learning Architecture, you can find a lot of free content on machine learning with these 3 platforms. You have the Great Learning Academy, where you can, again, as I just told you, you have multiple courses. You can get started for free, enroll for free, learn for free, and get a certificate of completion for free as well. So make sure you check out Great Learning Academy. Now, after Great Learning Academy, you have the Great Learning YouTube channel, a comprehensively put together channel where we have multiple subject matter experts training you on a lot of different concepts. So make sure that you subscribe to the Great Learning YouTube channel, guys. And for all the people who love reading blogs, and if you prefer reading over watching videos, we have Great Learning blogs as well. So you can read about your favorite topics, research about your domains, and eventually work your way to success as well, guys. But if you guys are very, very serious about your career, if you are looking forward to becoming complete experts, I would highly suggest you check out the offerings that we have in terms of specialization and post-graduation here at Great Learning. Now, we have multiple programs that are done in collaboration with some of the most prestigious universities across the globe, and even Ivy League schools as well, right? So we have multiple post-graduation programs, MTech programs, MS programs, certification training programs. So we have so many things, and of course you have to look towards these. Now, all the free content out there, is going to give you a good head start. It's going to give you a good amount of knowledge about the domain itself. But if you are willing to become experts, completely proficient in the domain, right? You're going to require one-to-one mentoring. You're going to be trained by all the experts across the globe. You will have thorough knowledge on it. You will be working on multiple projects, even looking towards the terms of job assistance as well. So guys, to get more details about this, I would highly suggest you check out the Great Learning website. Now guys, on that note, you have come to the end of the session. All of you guys, everyone in the audience, you have been beautiful. It's always my pleasure, to take a session for all of you guys, and you guys are highly interactive, highly energetic. If you loved everything you saw on your screen right now, guys, do take a second to hit that like button. It would mean a lot to us, and of course, make sure you subscribe so you're in touch with the channel. Stay in touch with Great Learning Academy as well, because this is where we'll be putting out courses on multiple different domains. No matter where you are in your career, you can make use of Great Learning Academy in one way or another. It is completely free of cost. Right guys, on that note, I wish you all well. Make sure you're staying safe from the ongoing pandemic. Keep your learning up, and I'll see you on the next one. Cheers guys. Thank you so much for tuning in. Have a nice day ahead.